This is the first session of computer organization. I think the first session we have given a detailed overview about computer organization subject. Now we are going to see the basics of first unit, or what are the some topics available in the first unit. I am just repeating what is the course objective. We already studied in the first session. So the course objective of computer organization to discuss and make student familiar with the principles and the implementation of computer arithmetic, or what are the various arithmetic operations involved, including the fixed point arithmetic and floating point arithmetic, even addition, subtraction, multiplication and division, and various algorithms for division and multiplication algorithm we are going to see in detail in the later part of the first unit. And after that, now the second unit, we are going to study what is actually the register transfer language, design of arithmetical logical unit, and what is actually the instruction cycles, how instruction is executed, and the bus structure also we are going to study in this program. The third important objective you can learn from this computer organization is you can able to identify or understand the different instruction set architectures like CISC and CISC machines and their relationship to the CPU design. The fourth unit, we are going to see what is actually memory, what are the different types of memories available, also what are the input-output devices available in the system, how these input-output devices are communicating with the CPU, what is the role of memory, shared memory. And the last unit, now we are going to see about instead of using single processor, how to make a system with the multiprocessor environment. Even though if you use multiprocessor, how multiprocessors are communicating and they are synchronizing. And also we are going to see how the pipelining concept is involved in enhancing the computer system operations. So these are all the main course objective of learning computer organization. At the end of the course, you can able to understand the different computer systems, can able to know various arithmetic operations, and also you can understand the functionality of central processing unit. Also you can able to see how I/O and memory organizations are arranged, and also we can see inter-process communication with the support of parallel processing. Now we can dive directly into the unit 1. The unit 1, there are two major categories of unit 1. First, we can see the basic structure of computers. That means we are going to see some brief introduction about these topics. Also, we are going to see something about the arithmetic, computer arithmetic. So, structure of computers, computer arithmetic are the two integral part of the first unit. The first unit, we are going to see the basic organization of computers, what is their historical perspective, what is the different bus structures, and the data representation, how data are represented, different data types, what is meant by complementation, and how to represent fixed point numbers, floating point numbers, and even other binary codes and error correction codes also. In the second part, what is the logic used for addition and subtraction, multiplication, various multiplications algorithms, various multiplier design circuits also available, and various design algorithms also available for making the design, making the division. So these are all the complete overview of the unit 1. These are the textbooks we already shared. The computer system architecture, Maurice Monod will cover the 90% of the syllabus. The second part, the Cal Amateur will cover the first unit, and it is a nice book for computer organization also. These are all the reference books. We'll start with these topics. What are the various different types of computers were available. Now all the day-to-day computers we are using, they falls under these 4 categories: embedded computers, personal computers, and the servers, enterprise systems, supercomputers, and the grid computers. We will see one by one what is actually the embedded computers. Embedded computers are special purpose computers that are designed only for particular purpose. So embedded computers are integrated into a larger device or system in order to automatically monitor and control a physical process environment. They are used for specific purpose rather than general processing task. embedded computers, they can able to use or used only for the particular purpose. We cannot use for general processing task. On where the embedded computers are mainly used, some of the typical applications include industrial and home automations where embedded computers are used, appliances, home appliances, telecommunication products, and even vehicles. For example, GPS system, like a ticket booking system, all that machines, kiosk machines. So all these the usage of embedded computers. Even user may not even be aware of the role that the computers play in such systems. Let's see some examples. These are all some applications of embedded computers where GPS in the car, we can able to control various devices in the home automations, automatic door opening, even almost all the IoT based computers, they comes under this category. Personal computers are occupying the majority of the computers in the world. So personal computers have achieved widespread use in homes, educational institutions, and business places, and even engineering applications, office settings, primarily for dedicated individuals. Why it is called personal computers? It contains necessary computing facilities for a single user or personal use. That's what the name's personal computers. The personal computers for single user requirements. For a single user, they need a keyboard, they need a CPU, they need a monitor, they need a power supply. So everything required for a single computational task that available in the computer. That computer we call it as personal computers. Normally the personal computers support variety of applications such as mainly the general purpose computation, document preparation or computer aided design, audio visual entertainment, gaming, even interpersonal communication, and the internet browsing. These are all the major areas where personal computers are heavily used. On some places where it acts as a workstation computers, they will provide higher computational capacity and more powerful graphical display capabilities for engineering and scientific applications, especially the CAD drawing, gaming applications. Sometime we will use the another category of personal computers. It is called portable computers, or some we can call it as notebook computers. So these versions of personal computers, they provide more basic features of a personal computer in a smaller and lightweight package, and they can operate on batteries like our laptop, palm top, even iPad. Like these computers are best example for personal computers. These are some pictures representing the personal computers. The next another end of personal computers, servers and the enterprise systems. So the servers and enterprise systems are larger computers where the necessity for computing environment is huge. For example, servers are recovered only few areas where we need a fastest computing environment, especially the rocket launching, atomic power plant pressure and temperature monitoring. These are all the places where we need a fast computer which will perform computations at millions of instructions per second, so that the servers and enterprise systems are heavily used on the particular area where we need high processing environment. It's some form of the personal computers over a public or private network. These computers may host large databases, maybe the database servers, web servers, like different categories of servers will be mainly deployed by using the server based computers, and they provide information processing for a government agency or any commercial organization like that. No, the cloud are mainly based on the servers. They have large varieties of spaces available. So these are all some examples for both servers and enterprise systems. These are medical applications where we can use only specially designed for that application. These are of the server environment where the computing power and storage capacity, for what purpose we are using the server environment. Apart from that, the supercomputers were available and the grid computers were available for in the market. Supercomputers and grid computers are normally offer the highest performance, and they are the most expensive, and basically the largest categories of computer consumes more space. Supercomputers are mainly used for the highly demanding computations needed in weather forecasting, engineering design, and simulation, where the scientific work is carried out. And one disadvantage is they have a high cost, but not compromised on the speed. Grid computers provide more cost-effective alternative, because instead of going for a supercomputers, a small computer they can combine and they will work as a grid, so that they can able to share the computational environment. So they combine large personal computers and the disk storage units in a physically distributed high-speed network. We can call it as it is a grid, which is managed as a coordinated computing resources. So where there is no need for supercomputers, no need to invest huge money on purchasing the supercomputers, we can go for grid computers, where multiple small sized computers are integrated, so that we can have a shared computing environment will reduce in the reduced cost. So by eventually distributing the computational workload across the grid, so the grid computers are placed in a vital role in many of the companies, and even large applications ranging from numerical computers to information searching. These are all some examples for supercomputers and grid computing. So this is a basic unit of a computer. This is from this topic onwards, your original syllabus starts actually. We're going to see what are the basic functional units of a computer. Modern computers contain memory, that is the shared memory, and another part there is a computational unit. The computational unit, we have arithmetical logical unit and control unit. So this is the entire area where the ALU and the control unit is available. We call it as it's a processing unit, or simply it is a processor. There are some external devices, they want to communicate with the internal system. This is actually the internal computer. So the input and output devices, they want to communicate with the internal part of the system or CPU. It is connected through some interconnecting network. This interconnecting network acts as an interface between these external devices to communicate with the CPU, so that the work will done, or the user can communicate with the system only through the input and output devices. Almost the memory is a very important component in a computer system, which acts as a shared memory, where almost data will be available for execution, for given execution to CPU. We'll see one unit at a time, one by one. So let's see about input units. Already you know, very familiar with the input units. There are various devices through which a user can interact with the CPU. So the computer accepts coded information through input units, or the input units may be through keyboard, through mouse, or some other communication facilities also available. The most common input device is the keyboard. Whenever a key is pressed, the corresponding letter or digit is automatically translated to its corresponding binary code and transmitted to the CPU, so that CPU can understand what is the task, actually what is the key pressed by the user. They can understand, the CPU can understand the action performed by the key. And there are other categories of input devices were available for human computer interaction are available. Very common input devices are touchpad. So through laptop or through other devices, the touchpad plays a vital role in input part. And very common mouse, joystick and trackball. These are all the common input devices available, through which the user can able to communicate in the form of actions or in the form of commands to the CPU. So the CPU can understand the user actions. The corresponding action will be performed inside the central processing unit. These are often used for graphic input devices in conjunction with the displays, because modern computers are all comes with the graphical user interface. So these devices helps the graphical user interface. Through graphical user interface can able to interact with the CPU. Other than the keyboard and standard other devices, sometimes microphones can also used to capture the audio input, which is then sampled and converted into digital codes for storage and the processing. Sometimes the microphones commands will be given, or the commands will be user commands will be given through microphones also, so that the coded the micro conversion, or that signal will be transferred to the CPU for further processing. Sometimes the cameras available in your system also can be used to capture the video inputs. Even internet connections like digital communication facilities such as the internet can also provide input to the computer from other computers and database servers. So these are all a brief theory about input units. So these are all some devices: mouse, keyboard, scanner, trackball, MICR, touchpad, touch panel, joystick, barcode reader, keyboard, OCR. All these are all sample input devices through which the user can able to interact with the system, or user can get work done from the system. Memory unit, we can directly go to the memory unit. The function of the memory unit is to store programs and data. So the role of memory unit is very critical in the computer system. Almost the CPU will read only the instruction from the memory. CPU will not read directly the instructions from other devices. So whatever may be the data, that should be placed onto the memory first, from where through memory cycles the data will be transferred to the internal registers so that the corresponding operations will be carried out. So memory is a very critical and important component. It's also sometimes it is called shared memory. Why? Because memory is common for all the devices, starting from IO devices, other peripherals. They want to share data to the CPU only through the memory units. So there are different memory are available. Two classes of storage called primary memory and secondary memory. We are going to see what are the different memories available in later 4th unit, but we will give brief introduction about the memory. So mainly primary memory, associative memory, auxiliary memory, cache memory, and there are other storage devices also available. We will see some brief overview about primary memory. So primary memory also called main memory. So whatever the term, either you can call it's a primary memory or you can call it is a main memory. It is a fast memory that almost the speed is synchronized with the CPU speed. That's what the data transfer between the memory and the CPU synchronized. The programs must be stored into the memory while they are being executed. Otherwise the CPU cannot execute user programs. So the user program need to be executed by the CPU. That program first it should be placed onto the memory. Then the memory read operations will be initiated. Through that it brought back to the CPU. CPU will execute. Normally memory contain memory cells. They are used for read or written individually. Instead they are handled in a group of fixed size called words. Normally the memory size or the memory transfer will be happen in the form of memory words, because memory contains so many different cells, depends upon the size. The data will not be read or written from the memory, not individually, maybe in the combination of words. The word size depends upon the system architecture. Some system or the conventional system, they use only 16-bit word or 32-bit word. So now the modern computers, they are using 64-bit word size also. It depends upon the architecture. The memory word sizes depends upon the architecture. The memory is organized that one word can be stored or retrieved at a time for one basic operation. All the data will be stored either within the size of one word. So the number of bits each word is typically referred from ranging from 16, 32 or 64 bits. It depends upon the computer architecture what we are using, whether we have a 16-bit memory. Now that system is called a 16-bit system or 32-bit system or 64-bit system. Extension to the primary memory. The primary memory is used to provide easy access to any word in the memory. Also, the memory is categorized, or memory is divided, or memory have distinct addresses, or it is called memory addressable. It is associated with each word location, starting from 0 to that n number of memory addresses. It depends upon the size of how many number of words available in the memory. Addresses are consecutive. And starting from 0, and it is identified in successive locations. A particular word is accessed by specifying its address, so that it is called a random access memory. So normally primary memory follows random access. By specifying the address, by giving the address, we can able to read data or we can able to store data. What kind of data normally available in the memory? There may be it's a set of instructions and the data can be written into or read from the memory under the control of the processor. The read operation or write operation will be controlled by the different control signals generated from the control memory. A memory in which any location can be accessed in a short and fixed amount of time after specifying its address is called random access memory. Random access memory, it helps you to read data directly by specifying, by reading or by specifying the address directly. So the normally primary memory, it won't support sequential access, so that we can directly access the memory location either for read operation or write operation. And next we are talking about the time, how much time it is required for transferring the data from the primary memory, or the speed of memory can be calculated. The time required to access one is called memory access time, or sometimes it is called latency. The time is independent of the location of the word. Wherever it is available on the memory, the time is common for all. Either we are accessing the data from the 0th location or we are accessing the data in the last location. So irrespective of the location of the data available in the primary memory, the memory access time is same for because of the random access nature of the primary memory. And normally how much? No, it ranges from nanoseconds to 100 nanoseconds for current ROM units. So the speed is the data transfer speed or the memory transfer, memory access time is between nanoseconds to or 0 nano or some few nanoseconds to 100 nanoseconds. But modern computers still faster than this one. These are all some examples for primary memory slots. It can be inserted onto the CPU so that the memory will act as a shared memory. The other important unit, cache memory. Cache memory, it is an adjunct to the main memory. It is used to support the primary memory. Sometimes the cache memory acts as a interface between the CPU and the primary memory. According to CPU, that cache memory existence will enhance the data transfer or the data communication between the primary memory and the CPU, because the frequent data or the frequently used data normally kept available in the cache memory, so that the number of hit will occur, the number of miss we can reduce. The CPU wants some data that is available onto the cache memory, then we can call it as it's a hit. If the corresponding memory or the corresponding content is not available in the cache memory, then there is a miss occur. There is a miss occur means then the primary memory will be triggered, the data will be brought back from primary memory to the CPU directly, and the copy of the data will be placed onto the cache memory. So the availability of the cache memory, it's used to support primary memory, so that the hit rate will be more. The number of hit rates more means automatically the execution speed or the performance of the system will get increased. The faster RAM units called cache, it is also faster RAM unit, but the size is very smaller when compared to the primary memory. So what kind of data the cache memory can hold when compared to the primary memory? Normally cache memory used to store a portion of the program which are currently being executed along with any associated data. So whenever the instructions which are currently executed, the user program have instructions which currently that program executing instructions are available in the cache memory, so that once it is completed, then automatically the cache content will be removed, the new content will be placed. There are different approaches are available that we will see in detail in the 4th unit. And the cache is tightly coupled with the processor, and it is usually contained the same integrated circuit chip. Because of that, the data transfer between the cache memory and the CPU is very fast, because it is available in the integrated chip of the CPU. The purpose of the CPU or cache is to facilitate high instruction execution rates. So if there is no cache means normally the number of instructions executed per second will be reduced, but the cache memory is used to help to increase the execution rate, high instruction execution rates. Initially, when the system is switched on, normally the content available in the cache memory is empty. Once the program is start executing, then the content will be transferred from the primary memory to the CPU, so that the frequently used instructions and its associated data are available in the cache memory. As the execution proceeds, the instructions are fetched into the processor chip and a copy of each is placed onto the cache memory, so that the next time if you want to read the same instruction or the CPU want to read the same instructions, no need to take the instruction from the data. It consumes more than one clock cycles, so that the data will be taken directly from the cache. Normally the cache to CPU, it will be completed within one clock. But reading from the primary memory, it is more than one clock cycles, so that everything is completed in one clock cycles, so automatically it will support to increase the number of instruction execution per time. Also, what are the other important concepts related with the cache memory? When the execution of an instruction recovers data located in the main memory, the data are fetched and copies also placed in the cache memory. Once, suppose the number of instructions are executed repeatedly, this happens in the program loop, then these repeated instructions are taken from the cache memory, not from the primary memory. Similarly, if the data locations are accessed repeatedly, while copies of their contents also available in the cache, they can be fetched quickly rather than going for memory. These are all some sample cache memory chip available in the system. The secondary storage also is called auxiliary memory devices. The primary memories, even though primary memory is essential, what is the problem with the primary memory? Primary memory storage size is very less, so we could not be able to store the huge programs, or the program size is more. Primary memory size is not sufficient to hold all the programs. Another disadvantage of primary memory is, even though it is fast, it is supporting the speed of execution of CPU. What is the problem with the primary memory? Primary memory contents are temporary only. So we need an alternate approach to store the user programs permanently in a system. That's what we are using the storage devices. The primary memory is essential. It tends to be expensive and does not retain information. These are all the two major problems with the primary memory. In order to avoid, we have an additional memory with less expensive permanent secondary storage are used for large amounts of data, and many programs have to be stored particularly for information that is accessed infrequently. So the storage devices stores the data permanently. Whenever there is a requirement, automatically the data will be taken from the secondary storage and it is moved to the primary memory. What is the problem of secondary storage devices? Access time is somewhat more than the primary memory, because it have to travel a lot distance from the CPU, from secondary storage to primary memory, then from primary memory to CPU. So normally that access time is longer than for a primary memory. There are various examples were available for the secondary storage devices. They are magnetic disk, optical disk, like a DVD and this CD. Now many of them we are using the flash memory devices. These are all best example for secondary storage devices. These are some example for secondary storage devices where we have DVD, CDs and even pen drives, even secondary hard disk. All these are floppy disk, magnetic tabs. So these are all best example for storage devices. And another important unit that is the heart of the processing unit or heart of the computer is called arithmetical and logical unit. So most computer operations are executed in the arithmetical logical unit of the processor. Inside the computer there is a CPU. The CPU contains arithmetical and logical unit. The arithmetical logical unit is responsible for doing all arithmetic and logical operations, which are the key for executing your user programs into actions. So any arithmetic or logic operations such as addition, subtraction, multiplication, division, comparison of numbers, are initiated by bringing the recovered operands into the processor where the operation is performed by the ALU. So ALU acts as a executor where all the instructions are executed. Different categories of instruction, arithmetic instruction, logical instruction, shift instructions, all the different categories of instructions are executed within the ALU with the support of control unit. For example, if we want to order two numbers located in the primary memory to be ordered, they are brought into the processor and the addition is carried out and the result is once again sent back to the memory or registers. So then the result may be stored into the memory or retained in the processor itself for any other secondary use or any other use. When operations are brought into the processor, they are stored in high-speed storage elements called registers. CPU normally contain arithmetical logical units, these collections of registers and control units. So what is the purpose of these registers? These registers are fastest storage unit available in the computer system. They can able to transfer the data among the processors. They can able to share data with the primary memory or in and out of primary memory to CPU. The temporary storage elements available in the CPUs are called registers. There are a number of registers available, depends upon the architecture. There are 64, it depends upon the numbers. And each register can store one word of data. At a time, it can able to store one instruction. There are different categories of registers also, instruction register, data registers, accumulator, program counter, like that there are different registers were available. Access time to registers are even shorter than the access time to the cache unit of the processor. So the time taken data transfer between the two registers is very low and even it is executed in one clock rate. So their execution speed is in clock rate. It is synchronized with the system clock. So these are all arithmetical logical units available. This arithmetical logical units is responsible for all the calculations, computations. Next we'll see in the output units. The output unit is the counterpart of the input unit. Its function is to send the processed output to the outside world so that the user can able to see the processed output from the system. One familiar example for such device is printer and even monitor. Most printers employ the techniques available in the printer. The printers may generate output at speed of 20 or more pages per minute. So their working speed is page per minute, ppm, we call it as it's a ppm. The printers are mechanical devices and such as they are quite slow compared to the electronic speed. Some units such as graphical displays like monitor provide both output function nowadays for modern mobile phones. The output device also act as an input device because it comes with the touch panel, so we can able to see the screen also. We can interact with the system through the touch panel only. Both they act as input function and output function also through touch screen capability. The dual role of such units are called input-output unit. So most of the modern computers, they do both input and output devices are integrated in a single component. So these are all output units, different devices of output unit. And the main, the heart of the central processing unit is control unit. The control unit is to control the overall operations of the computer through the system generated control signals. I think we have two different categories of control signals: hardware generated control signals, software generated control signals. The memory, arithmetic and logic IO units store and process information and perform input-output operations. How these operations are controlled? Operations of these units must be coordinated in some way. Control unit is the coordinator for all their operation. This is the responsibility of the control unit. The control unit is effectively the nerve center of a computer that gives control signal to other units and sends their states and checking their status. No, everything is controlled by the control signals. Either we are interacting with the external devices, or how output devices are displaying, or how the input devices are interacted. Whether we want to check whether the input devices are ready, we want to check whether the output devices are ready to display all this status information and control information. In memory also, whether we are electing the read operations or write operations, everything is controlled by the control unit. So the I/O transfer consisting of input and output operations are controlled by program instruction that identify the devices involved and the information to be transferred. There are control circuits. These control circuits are responsible for generating the timing signals that govern the transfer and determine when a given action is to take place. These timing signals ensure that all the operations are carried out within the time bound, and the data transfer between the processor and the memory also managed by central control units through the timing signals, or we call it as it's a clock signals. We have to ensure that all the instructions are executed within the time bound given by the time signals.
Hello everyone, welcome to the course on.
So it is reasonable to think of a control unit as a well-defined, physically separate unit that interacts with other parts of the computers, because normally the control signals are used to control various parts of the devices or peripheral devices attached, buses, memory, input devices, output devices, other peripherals. So much of the control circuitry is physically distributed throughout the computer. Even every devices also, they have a control circuitry to check the status. The large set of control lines carries the signals used for timing and synchronization of event in all the units. So these are all the basic operations of the control unit. The main important operation of a control unit is the computer accepts information in the form of programs and data through an input unit and stores it in the memory. That is a operation of the computer can be summarized. Information stored in the memory is fetched under program control into an arithmetic and logic unit where it is processed. Next step is processed information leaves the computer through an output unit. All activities in the computers are directed by the control unit. These are all the how operations will be carried out. The first step is computer accept from the user, then it will process in the CPU used with the help of ALU. Then the processed output will be once again sent back to the memory. Through the memory, it will send back to the output unit. All these interactions or operations are controlled by the control unit. So this is a control unit. We'll see. So the next part we will see the historical perspective of various computers that is available. We'll see next session.